So the purpose of this is a math hospital, and what a math hospital is we are trying to address some issues with each of these problems. They're common mistakes that we have. I'm going to zoom into this first one here. Math hospitals are really important for us to understand what is good and what is not good, or finding the errors of other people. And so I will try and use blue throughout most of this video, just so that we have a consistent color, because most of the problems are black and red. I'm going to go through and I'm going to start thinking about each problem comes in sick. Something is wrong with each one and needs to be fixed, and we need to decide where the problem is and how to fix it. So when I look here, I see this is an overall, and I'm going to zoom in even more. I notice that I have an addition problem that's going to turn into a division problem. So I first need to do the numerator. So I've got x squared and x squared, that's 2x squared. Okay, they did that right. 5x and 6x, okay, that's 11x. They did that right. 20 minus 6 is 14. Okay, they did that right, and then they copied the x minus 2 down below. So now it looks like they're doing division. If they were doing division, I'd hope that they would put the little arrows in. I really think those arrows are kind of important. But if I were them, I'd start with this upper left corner, and that goes directly in there. So 2x squared. X squared, or x times something gives us 2x squared. That doesn't look like it's what gives us that. That makes it too big, so we really only need, I think, just 2x up there. And I think that fixes most of our problems. 2x times x is 2x squared. 2x times 2, how did they get that? I think that should be shouldn't that be a 4? I think that should be a 4, because 2x times 2 should be a 4. So let's fix that, make that a 4. That's not a 6, it's a 4. Okay, and so 4 plus something gives us 11. Well, that can't be 5. That can't be 5, so that can't be 5. So these are all kind of a resultant of this first thing being 4 plus something is 11, or 11 minus 4. It's going to be 7, I think. 7, which means that's not right. That's got to be 7. Oh, okay, so this is my new answer, and that's what should go over here. And so instead of that, we really should just have 2x plus 7. So if I were to do this problem fresh, or even this problem fresh, I would need to do a lot of things a little bit differently, as I try and zoom over here. So let's start it completely fresh. I've got a box. I've got the 2x squared. I've got the 11x. I've got the 14. I would start 2x squared. Oh, I know that. We're dividing by x plus 2. So that's got to be 2x up there. And I think that I should do it in a different color. 2x up there. Pull down, it's 4x. 4x plus something is 11. That's 7x. That means that this up here has to be 7x, and this has got to be 14. There's my check. My answer is right there. So I'm going to quickly move on to the next one. I think it might be easier to just start redoing these problems once I find the error that the person made. So our original problem, x squared minus 4 times x plus 3. So that's a multiplication problem that I have to do before I do anything else. Minus x squared plus 2x minus 5. So I'm going to start doing that multiplication. X squared minus 4 is one dimension. What's wrong here? I am starting to notice x squared times x is x cubed, negative 4 times x is negative 4x, x squared times 3 is 3x squared, negative 4 times 3 is negative 12, but the diagonals don't line up. So while they may have done this multiplication box correctly when they took things out, this is all problematic here, because it looks like they didn't consider the diagonal had like terms. So this is all wrong there. But did they copy this down correctly. So I've got negative x squared plus 2x minus 5. Okay, I think I need to restart from this box. I think I need to restart from ground zero here. But it looks like they made the error right there. So if I redo their box of x squared minus 4, x plus 3, x cubed, negative 4x, 3x squared, negative 12. It looks like the polynomial that I get out of this is x cubed plus 3x squared minus 4x minus 12. And then I've got to deal with all of this subtraction. So I'm going to move over. I think I'm going to just move over. Okay, and then I'm going to move all of this over here. Maybe I shouldn't have done it right underneath, but gotta move this black stuff. So minus x squared plus 2x minus 5. So I see that I now have just a subtraction problem, and I've got a subtraction problem. I've got to distribute that negative. So I'm going to rewrite everything. So x cubed plus 3x squared minus 4x minus 12, the negative x squared, negative 2x, and then a double negative, it's a negative 5, becomes a positive 5. And now this is just combining like terms. So it looks like I only have one x to the power of 3. X to the power of 3. I've got an x squared and a negative x squared, so that gives me 2x squares. And then I've got a negative x and a negative 2x, negative 4x, so that's negative 6x. And then I've just got my regular old-fashioned numbers. The negative 12 plus 5, that's negative 7. This is the correct answer to the previous math problem, but we just got to make sure that we do it right with the multiplication, and then distributing that negative sign is probably one of the more challenging things. Okay, let's zoom out. Let's look at the next problem. So, considering this, where did they make their mistake? Let's be really clear. So it's x minus 3 to the power of 3. That means there's 2 of them there, and another one that gets multiplied. So it looks like what they did is they took this and they started doing a multiplication problem with it. Okay, did they do that right? X minus 3, x minus 3. Oh no, what did they do? Oh, I see. So the first thing they did was they noticed that they can take the denominator and it can be divided by 3. It can be divided by x minus 3 because they took this denominator and they kind of did reverse division. That's kind of weird. X squared went in there, and the negative 6 goes to those two, the 9 goes there. And then they discovered that x squared minus 6x plus 9 is actually, oh, I see, is x minus 3 times x minus 3. Okay, so they're breaking up this multiplication where this is the thing that's multiplied by itself 3 times. So x minus 3 squared times x minus 3. I suppose what they could have done, and let's see if I can get it to work, is they could have rewritten this as x minus 3 times x minus 3 times x minus 3, because it's x minus 3 to the power of 3. You know, I'm starting to wonder if they even made a mistake here. And then they took this and they divided it, so they knew that this was x minus 3. x minus 3 times x minus 3. Oh, this is a tricky problem. I got so many x minus 3's flying around all over. Oh, I see what they forgot to do here. They're not done. That's the only thing that's wrong with this, is they're not done. Because it looks like they canceled this with this. But then I think we can, if we look up at this the top one up here, you can cancel out 2 of them if they're all fully expanded. So those cancel out, and the thing that I'm left with, I think they can cancel out one more. The thing that I'm left with is really just x minus 3. So it's not that this is wrong, it's just incomplete. That's just incomplete, and this would be our final answer, the x minus 3. This is a tricky problem. So it's not that they're wrong, it's just that it's incomplete. So there's only one more on this page, and we'll talk about it as quickly as we can. It looks like there's just a lot of stuff going on here, so we'll talk about it. It looks like when I read this problem, x plus 7 times 2x minus 3, we need to do a multiplication problem. There's a subtraction problem of a division problem. Oh, I have to use PEMDAS. I've got to do the multiplication and division before I do this subtraction. So let's check it out. X plus 7 goes on the top there. 2x and minus 3, did they do that right? X times 2x is 2x squared. 7 times 2x is 14x. X times negative 3 is negative 3x. 7 times negative 3, those are like terms, they can combine, so it looks like they did the multiplication right. So I'll give them a green check for that. Nice job. And then I'm thinking, okay, division. So x cubed goes in there. Again, I really would love if they would have put these arrows in. So that I know what goes where, because otherwise it's kind of hard to tell where things go. Let's look to see if they did that. So x to the power of 3 goes there. That looks right. And carry it down. That looks good. Negative 2. Uh-oh. Those don't add to that. But I know that that has to be right. So I think that's wrong. So we got to get rid of this. That's not right. What should it be? I think it needs to be just 0. Yeah, it just needs to be 0, because then everything else looks... if I look down, 0 plus x is x times 1. It looks like everything else works out. So they didn't get the answer wrong, they just got this one cell wrong. Okay, so x squared, that gotta be a minus 1? Uh-oh. What did they do here? X squared, it should be plus 1. And why is that a minus? Because I think if I, okay, so this is where they flubbed up right there, is we got to make sure that when we carry this down, it's still a minus sign. And then we've got this stuff, and that shouldn't be a positive one. It shouldn't be a negative one. It should be a positive one. Okay, now I think they've got it. Right. So I'm going to rewrite what they have right, kind of over off to the side. So they had this 2x minus 11 minus 21. They had that good, and so I just want to make sure. So we've got that. What was it again? It's 2x squared minus 11x minus 21. So I'm just going to recopy that over here. 2x squared minus 11x minus 21, and then they needed to have minus in parentheses x squared plus 1, x squared plus 1, x squared plus 1, and they need to then distribute that. So I'm going to rewrite everything again. It's a lot of rewriting, it seems like, isn't it? Minus 11x minus 21. That's a negative x squared, a negative 1. Okay. Then I'm going to combine like terms. 2x minus x is x squared. 2x squared minus x squared is x squared. I've got my negative 11x, and I've got my negative 21 and my negative 1. That makes negative 22. So it looks like that's not our answer because they did something weird there. That's not our answer, but we've got our final product here. I know this video is a little bit confusing with all of the little steps that are involved, but I think it's a good process of identifying potential errors in our thinking so that we know how to approach them appropriately next time. Hopefully this video wasn't too confusing. If not, if it was, go ahead and look at another video. Hopefully that will be a little bit more clear. Error analysis is one of the best things you can do for your brain to understanding a concept. Thanks for watching.